Good morning, students and parents. I'm Arthur from the Department of Electrical and Computer Engineering. Welcome to this session on Electrical and Computer Engineering. And I'm going to explain to you more about what is the Electrical Engineering and Computer Engineering program about in NUS. Before I go deeper into the content, let me first show you a video of an introduction on Electrical and Computer Engineering.
Electrical and computer engineering encompasses a range of fields that form the backbone of our modern digital economy. At NUS, we offer 2 degree programs in electrical and computer engineering. Students on both programs get to work on projects covering themes from Internet of Things and autonomous systems to energy sustainability and smart healthcare. Some students have even designed and built satellites that have been actually launched into space.
From the processors that power our mobile phones to autonomous vehicles and augmented reality, electrical and computer engineers are behind the most transformative innovations. Electrical engineers create technologies from tiny microchips to electric vehicles to nationwide power grids that use electricity and electromagnetism. Computer engineers build intelligence into ever smaller, smarter, and more powerful devices that enrich modern life.
At NUS Electrical Engineering, there are a lot of opportunities for hands-on learning. For example, the lab modules in which we build and experiment with electrical circuits really help me understand and appreciate the theory. There are also a lot of opportunities to learn different coding languages, skills that are highly sought after by employers.
NUS ECE offers many focus areas for you to develop your strengths and interests. For 2 years, I was president of the ECE Undergraduate Student Council. There, I developed my leadership abilities, organizing school events such as the internship and career fair. Through the modules I've taken, I've learned various skills critical to the AI field, such as machine learning and natural language processing. These skills are highly relevant in the career that I'll be pursuing after graduation.
At NUS ECE, students plan their education to match their interests and career aspirations. We combine a strong emphasis on learning the fundamentals with a high degree of flexibility, mixing education, business, and research opportunities. Our students can also embark on various industry tracks and specializations, from AI and data engineering to robotics, as well as in exchange programs and entrepreneurship opportunities at NUS overseas colleges. Electrical and computer engineering opens up a world of discovery, preparing you for careers that are full of exciting challenges. ECE graduates work in fields such as research and development, design, manufacturing, banking, management consulting, and software development. Some alumni have even launched their own businesses that find innovative ways of applying electrical and computer engineering technologies.
Our programs are designed to develop versatile engineers primed and ready to work at the cutting edge of the digital economy and the smart nation. Join us for an inspiring university experience, preparing you for an exciting career that innovates for the future.
Okay, I hope you have a better understanding of what electrical engineers and computer engineers work on. Over at NUS, the Department of Electrical and Computer Engineering is one of the major departments in the College of Design and Engineering. We have about 100 faculty staff, of which 30 are professors from the industries that provides industry-relevant content to our curriculum. In terms of student numbers, for undergraduate, we have about 1,500 students, over 2 programs in electrical engineering and computer engineering. Each year, we take in about 200 students for electrical engineering and 200 students for computer engineering. Both our undergraduate degree programs are accredited by the Engineering Accreditation Board. This means that your degree is recognized worldwide under the Washington Accord. For the computer engineering program, it's actually jointly offered by the Department of Electrical and Computer Engineering and the Computer Science Department. So you will get to see computer engineering in both departments, they are actually the same program. There's only one computer engineering program in NUS. So what do electrical engineers do? Electrical engineers design, develop, and build technologies that make use of electricity, electronics, and electromagnetism. And it covers a wide range of topics from the very small scales of quantum computing, your nanomaterials, into your integrated circuits, computers, AI, machine learning, robotics, autonomous vehicles, to the very large scales of power grid systems, computer networks, and Internet of Things. Electrical engineers actually make many impactful contributions over the past centuries, right? So electrical engineering underpins rapid economic growth in the 20th century. Major technologies include transistors, which results in what we have now in our computers, telephones, radios, the internet, and diagnostic imaging essentially changed the way that healthcare is treated today. Going forward, there remains many opportunities and challenges for electrical as well as computer engineers. Electrical engineering and computer engineering is enabling the new economy of the 21st century. There's a lot of opportunities in areas because we want more powerful mobile devices. We want to develop more efficient AIs and machine learning algorithms, more safer autonomous vehicles, robotics, wireless communication, renewable energy, and enabling better cybersecurity in connected systems. So what is computer engineering? Computer engineering is a branch of engineering that integrates several fields in electrical engineering and computer science that is required to develop computer hardware and software. Typically, computer engineers will have training in electrical engineering, software design, and hardware-software integration instead of only software or electronic engineering. So over at NUS, the computer engineering program is a specially curated program. It's not a mixture of taking some modules in electrical engineering or some modules in computer science, but there are actually modules developed just for this program. So earlier today, you have heard about our new CDE curriculum. So as a students that come into the engineering program, you typically need to take 40 courses to graduate. So over a 4-year period, each year you take about 10 courses. Out of these 40 courses, the 15 which is shown in the blue color block is what we call the common curriculum. So under this common curriculum, you have 6 courses in general education pillars. These are modules which the university wants every single student to take, right? And then there's 7 common pillars. These are modules which all CDE students will have to take, things like artificial intelligence, makerspace, project management, and design thinking, and then follow up with an integrated project, which is usually your final year project. The next block, which is shown in orange, is the major requirement, and over here there's 15 courses which each major will require you to take. For example, in electrical engineering, there's 15 courses that we want you to take, and similarly in computer engineering, there's another 15 courses that we want you to take. And the last block in gray is what we call the unrestricted elective, and so over here there's 10 courses, and it is through this space that you can explore different opportunities based on your passion. So for polytechnic students, you are exempted 38 units in the following courses. So 38 units is about a year of coursework. So typically you can graduate within 3 years. So because of the new curriculum, as shown in these slides, you actually have unlimited learning pathway, right? So under the unrestricted elective, you can, for example, if you are doing electrical engineering, you can go further in-depth into electrical engineering modules, or you can do a second major in maybe economics, or you can even do elective with a minor, do 2 minor, or a minor and a specialization. So in NUS, we have more than 30 majors and more than 60 minors for you to choose from. So this next slide shows you the different possible career path that you can embark on depending on the options that you choose under the unrestricted elective. So for example, if I look at the second column, if you do a major in electrical engineering or computer engineering, and then you embark on a specialization in robotics and a specialization in space technology, when you finish this program, you can go out and join the space and satellite industry, right? If you look at the fourth column, let's say you do electrical engineering, you then do a minor in public health, and then together with this new minor in computing, which you have heard earlier today, you can then join the healthcare workforce, right? So in Singapore, we are trying to move healthcare from the hospital to the homes, and many of these requires digitizations and understanding the public health systems. And a program like this will allow you to do that. And there are many other different opportunities. We welcome you to come to the physical open house and chat with our students and professors to find out about them. So what will you learn in terms of the major? So this table shows you what are the major courses in electrical engineering and computer engineering. So you can see that there's quite a bit of similarity between the two programs. Things like signals and systems, both programs will need you to study digital design, transistors, etc. Right? So we put a strong emphasis in the fundamental and experiential learning. Both programs, if you look at it, the first two courses is called the Electrical Engineering Principle and Practice 1 and 2, or the Computer Engineering Principle 1 and 2, right? So this is a 100% lab-based course where you go into the lab, you build your robots, and from the process, right, doing the hardware as well as software, you understand why the theories are important for you. Like what I mentioned earlier, under the unrestricted elective, you don't do a second major or a minor. You can, in fact, go more in-depth into different domains in electrical engineering. So over here, these are some of the courses available for electrical engineering elective, right? From areas in communications and networks to signal systems, power and energy systems, intelligent circuits, embedded systems, robotics, and control systems. So opportunities to go in-depth and specialize in different areas is there. The same goes for computer engineering. So in computer engineering, we have 6 main areas for technical elective in communications and networking, embedded computing, large-scale computing, system-on-the-chip design, intelligent systems, and interactive digital media. So one of the highlights over at the Department of Electrical and Computer Engineering is we constantly engage in dialogue session with the industry partners to understand what are the current needs in the industry. And based on these current needs, we then adapt our curriculum so that our graduates will be ready when they join the workforce, right? So like, for example, over the past couple of years, there's a strong emphasis on Industry 4.0, electric vehicle, the semiconductors, and more recently, space tech R&D. And because of this, we actually have 4 new specializations that came out over the past years, right? So originally, our specializations are just Internet of Things and robotics, but recently we have the Industry 4.0, space technology, advanced electronics, and sustainable electric transportation. So each of these specialization requires 5 courses, and you have many options on what to take in that 5 courses. We also have a minor in data engineering that will teach you techniques, infrastructure, and frameworks to tease insight into the huge data streams that you can generate from it. So those of you who are interested in this, you can also explore doing a minor in data engineering. So something that is going to start next academic year, right? So students doing electrical engineering will now be able to do a second major or minor in computing. So in the past, electrical engineering students are not allowed to do a second major or minor in computer science due to the similarity in both programs, right? But we understand there are some computing aspects that students are interested in, and we have come up with this second major and minor in computing, which aims to equip students with interdisciplinary knowledge and skills in computing related to design and engineering. And students will be able to learn fundamental computing concepts, analyze complex problems, use computing-based tools, and apply cross-disciplinary techniques to design solutions with digitization and automation. And I encourage you to join us on our open house, talk to our students as well as professors to understand more about this new exciting program. So next, I want to share with you a couple of our student projects. So the first one is this Nano-Satellite Education and Research Program, where our students, undergraduate students, gets to work towards launchable nano-satellites. You also have the opportunities to do internship at companies that have satellite programs, such as DSO National Labs, ST Engineering. Students can also look forward to exchange with universities with established satellite programs. And over at NUS, we have our own Space Technology and Research Center. Okay, just last April, our undergraduate students built some nano-satellite that was actually launched into space. Next, we have this very famous Team Bumblebee. So this is a multidisciplinary student team consisting of students from electrical engineering, computer engineering, mechanical engineering, and some computer science students, where they come together and build underwater as well as surface vessels. So let me show you a video to show you what are the things that they have done.
One of the main challenges of designing an autonomous system is knowing what you should be doing at the right place and at the right time. If we are just dropped into this competition, we should be able to go and do at least a few tasks without me having to code anything. That is actually very difficult to do.
The technology that we develop, the knowledge that we learn, I believe one day itself will actually be used in discovering something unique in the ocean. The ocean is just out there for us to discover. We just need more of this competition and talent.
Okay, so if you join NUS, I hope that you can participate in their introductory workshop and explore more about possibility of joining their program. Electrical engineers and computer engineers actually contributes to the fight against COVID-19 as well. So if you recall, during the circuit breaker in our foreign workers dormitory, there's a high cases of COVID-19 infections. And one of the indicators of COVID-19 back then was that there's a drop in your blood oxygen content. So if you recall, every household has this pulse oximeter, right? So what we have done is we went into the workers' dormitory, we set up an infrastructure to automatically upload all this SpO2 reading, this blood oxygen content reading, to the cloud, and then display on the dashboard. So the manager can now see who is feeling unwell and who is well, and you can see data as well, okay? So more than just electrical engineering or computer engineering, there's other opportunities as well, right, to broaden your framework of study in NUS. So you can do double degree, major or minor programs. So for double degree program, one of the common one is engineering with business administration. You can also do engineering with another bachelor degree in the College of Humanities and Sciences, and the common one is economics. So over here, Yixian, who graduated in 2022, he actually had a double degree in electrical engineering as well as economics. The same goes for, there are more than 30 majors and more than 60 minors for you to choose from, as shown in this table. The QR code actually brings you to the major and minor website, which you can have a better understanding of what are the available programs, right? So for electrical engineering, there's now the new second major or minor in computing, which you can join. If you have a keen interest in medicine, you can also do engineering and medicine together, right? So we have partnered Duke NUS Medical School, where you can, in the first 3 to 4 years, you do an engineering degree, and then you can go on to do a Doctor of Medicine at Duke NUS Medical School. And when you graduate, you can practice as a general practitioner, as a doctor, but you can also become a clinician scientist to involve in engineering and medicine type of research, right? So Xizhi over here, who graduated from computer engineering, is now studying her Doctor of Medicine at Duke NUS. Student exchange program, right? So we encourage every of our students to go for exchange program so that you understand how different university the education works, etc. Right? So you get to study a semester or two at more than 100 partner universities worldwide. And NUS Engineering is the only engineering school in the world to have exchange with both Oxford and Cambridge. If you don't want to go for a semester-long type of exchange program, you can also do shorter summer or winter programs at more than 30 partner universities. One of our flagship program is the NUS Overseas College program, right? So this is for students who have a strong interest in startup as well as technopreneur or entrepreneurship, right? So what you can do is, for example, if you do electrical engineering, we'll find a startup company in Silicon Valley where you'll go over there and work 1 full year as their employee, right? But if you work 1 full year and don't study, then when you come back, you'll delay graduation by 1 year. So how the system works is that while you are working there, you will study at the partner university. So in this case, at Silicon Valley, the partner university is Stanford, right? So you take some modules there, and then when you come back to NUS, your delay in graduation is typically about 6 months. So there's more than 10 overseas locations for you to choose from. So what are the possible career options, right? So based on your unique training in hardware and software as an electrical engineer or computer engineer, it actually opens up a wide range of roles, such as, for example, AI and data engineer, a cybersecurity engineer, health tech engineer, innovators, semiconductors, or smart device developer. So the following slide shows some example of what our graduates has been working on. So for example, on the top left, I have Ankita over there. She's actually from electrical engineering, right? So during her final year, she worked on the healthcare related projects, and actually she's interested in that space. When she graduates, she's now working as a software engineer at Tan Tock Seng Hospital, right? Then I have Lionel over there, who is a technical product owner at Dyson, and Sandra, who is in electrical engineering, is now working as a cybersecurity engineer at CSIT. On the bottom left, I have Rishabh. So for those who have been reading the newspaper, you must have seen his face over the past few months. So Rishabh actually participated in our NUS Overseas College. So when he come back, he actually started his own company on robotics. So he's building the next generation of robots that will help to clean our toilets. So in the coming months, you will get to see his robots moving around and cleaning the toilets in the various shopping malls, right? And then we have Edward that is working in GovTech, and Ramon, who is a software engineer at Google Pay. So like what I mentioned, there's actually a wide range of different industries that our students work in, right? So from the research institutes to the big tech company like Google and Apple, or the oil and gas industries, the banks, the semiconductors, and the telecommunication companies. So in terms of the starting pay for our graduates, right? So every year, MOE will publish a graduate employment survey, and over the past couple of years, electrical engineers as well as computer engineers has been in high demand, right? And their pay has been going up. So this is partly due to, right, our drive, Singapore's drive to a smart nation, right? And because of this, a lot of digitizations, automations, type of skill sets is required. So this is for the table for electrical engineering, and there's another one for computer engineering. Some of our alumni that have participated in the NUS Overseas College, or the more entrepreneur type. So if you look at the figure on the top, I have Teo Sui An. He's our electrical engineering graduate. His passion is in building microcontrollers. So he actually started a company called Expressive, which is listed in the Shanghai Stock Exchange. And on the bottom left, I have Darryll. Darryll actually went for the NUS Overseas College. So when he came back, he started his company 10Cube, and now he has a different company called 99.co. So for those of you who are looking for accommodation, renting your apartments, or buying new apartments, you must have come across his platform. And then during the past few years, I'm sure everyone has been purchasing things online, right? So you must have made use of the Carousel platform for that. And one of the founders for Carousel, Lucas, at the center over there, he's actually from the computer engineering program, and he actually went for the NUS Overseas College as well. So why NUS Electrical and Computer Engineering? One of the key things in the NUS General Education Framework is that of an educated person. And we teach you skills needed for lifelong learning, not just what is required for the next 5 years, but throughout your career, right? So critical soft skills are covered in various courses such as project management, engineering professionalism. Within the program level at Electrical Engineering and Computer Engineering, many of our modules have experiential learning content, right? So you get to work together as a team, build different robots or solve different problems. We also have small group teaching. So sometimes a class might have 200 students, but we break them up into 4 small groups so that you can have better time engagement with the professors, right? And the professors can also understand the students better. We also invite industry speakers for many of our courses so that our students understand how these theories can be applied to the industries. Workshops are also conducted by industry partners, right? So for example, recently there's an IoT workshop by Expressive Systems, right? And this also shows you alumni is an important group of people within the NUS community, right? So they graduated from electrical engineering and they come back and contribute back to the program. We also conduct industry visits for our students to various companies. So when you join NUS, electrical engineering or computer engineering, we also help you to prepare yourself better before you come in, right? So before school starts, we usually conduct maths refresher course, and this is really useful for our NS boys, right? Orientation camp for you to get to know your friends better, peer tutoring for some of the core courses. Sometimes we do learn better from our classmates, right? And then there's always get together every semester with your peers and your advisors. So it is not all about studies. Student life activities is something that we encourage you to participate on, either in sports, music. There's a lot of different programs available in NUS. We also have this Shannon Study Award for students that is doing electrical engineering. So in this study award, you'll be given 15K, 7.5 in year 1 and 7.5 in year 3. The requirement is that you need to have good A-level, Poly or IB results, and then you're a Singapore citizen. So if you want to find out more, you can talk to us during our physical open house. These are the admission requirements for A-level, IB diploma, as well as polytechnics, right? So for electrical engineering, the main requirement is you need to have H2 mathematics. And then for computer engineering, you need to have H2 mathematics, physics, chemistry, or computing, right? And the table below shows the indicative grade profile, right? So for last year. The closing date is 19 March 2024. We have also prepared a series of programs for you to find out more about our NUS Electrical Engineering and Computer Engineering program over the next few weeks, right? So on 8 March, we will have this NUS ECE Students Sharing webinar that will be conducted via Zoom. Then on 9 March, the actual physical open house will provide opportunities for you to sample some projects, right, and workshops in robotics where our electrical engineering students and computer engineering students actually do, right? So I do encourage you to sign up for these sessions. And then on 15 March, we have a NUS ECE alumni sharing session where our alumni, especially the young alumni, they will share with you the modules that they have taken previously and how it has helped them in their current work. So over on the top right-hand corner, I have the ECE Open House microsite. You can go to the website and find out more information about all these different events. And then do join us on our Telegram. Our students will be there to answer all the questions that you have. And finally, feel free to contact us. Our hotline is shown there, or you can also email us and we'll try to answer your question. Thank you very much.
Hi everyone, I'm Barbara. I'm year 2, currently pursuing a double major in computer engineering and social work in NUS. I'm also part of the e-Scholars program. But before I delve into that, let me take you back a bit. I'm from VJC, where I was from track and field as well as the Interact Club. So now, why did I choose NUS and specifically computer engineering? Well, to be honest, I chose NUS at the start due to the vibrant campus life and the exciting hall stay. But as I delved deeper, I realized that NUS was not just about the student life, but also the endless opportunities that it offers. As for computer engineering, it was a blend of passion for technology and my desire to make a meaningful impact on society. My grandmother, who struggles with mobility issues and mild dementia, inspired me to explore and research on how technology can be used to enhance the lives of the elderly and the differently abled. This drive to utilize technology to create impactful solutions for society led me straight to computer engineering. I'm also in the e-Scholars program. This is a premier program which offers an accelerated track to complete your engineering degree in 3 years with a 1-year master's. For me, being part of the e-Scholars meant more than just an expedited academic journey. It also means finding a supportive community right from the very start. I found an incredibly helpful group of friends who became my pillars of support throughout my time here. Together, we navigated the confusing uni life, like which course to take and what activities we want to take part in together. In the past 2 years, my journey in CEG has been nothing short of exhilarating, with many ups and downs. In CEG, we learn both computer science and electrical engineering. For the software side, we learn languages like C, C++, and Java, and embarked on software projects like using Java to make a system for task management. In CEG, we learn how to use hardware description language to automate and build robots using an Arduino, Raspberry Pi, and Verilog. I chose CEG because it's more holistic, and this has an advantage when we go out to work because we have a more diverse skill set encompassing programming knowledge, digital circuit design, computer architecture, and many more, mastering both the hardware and the software side, which increases our employability in the future. I also stay at RC4, one of the residential colleges in NUS, and it has been so exciting. There's many different interest groups and events like formal dinners, inter-college games. Some of the interest groups that I went to is basketball, arts and crafts, coffee, baking, and tea sessions, just to name a few. They are all really open to beginners, and you can really make many new friends here. Giving back to the community has always been a priority for me, and NUS provides ample opportunities to make a meaningful impact. Through initiatives like Y-Craft, I've had the privilege of volunteering with primary school children at Jurong West Primary School, where we engage in recreational and educational activities with them there. And every moment spent with the children at Jurong West Primary School has been incredibly rewarding. A group of e-Scholars and I also created a group called AI Thinking, aiming to teach people how to use AI tools like Midjourney and Stable Diffusion. We organized hackathons and workshops, and this gave me the opportunity to delve deeper into my passion for artificial intelligence. Besides all this, I have been participating in overseas trips by NUS. In Year 1 Sem 1 winter, I went on a 3-week-long exchange to Korea University, and at the start of this year, I went on an entrepreneurship program to Bangkok, where I learned more about the startup scene and how to pitch my ideas. So there are many opportunities that NUS provides, from overseas programs like winter school in Korea that you can just go after 1 semester in NUS, to entrepreneurial ventures through the NUS overseas colleges, where you get to work at a startup and study at the same time. The possibilities are endless. Personally, I myself am going to Norway for student exchange next semester, as well as hoping to go NOC in Europe in Year 4 Sem 1. To all of you that is entering university life this coming August, don't be nervous about this next phase of your life. University life is definitely a whirlwind of experiences waiting to be embraced. Just step out of your comfort zone, try new things, because time will pass very quickly. Thank you.
Hello, Welcome to NUS Open House 2024. My name is Fan Qing Yao and I'll be sharing my experience here at NUS Electrical Engineering and hopefully help you guys make a more informed decision. Just a quick little self-introduction before I start. I'm currently a Year 2 student majoring in Electrical Engineering with a specialization in Internet of Things and a minor in Data Analytics. So, why did I choose to come to NUS? Two main reasons. First of all, there's a lot of flexibility when it comes to choosing what I want to learn. Secondly, the rigorous academic curriculum and exciting student life here will be able to provide me with a rewarding university experience. On that note, why did I choose to pursue a degree in electrical engineering? Personally, I've enjoyed doing math and working with numbers all my life, and there's a lot of math involved in EE. I also love doing hands-on stuff, and EE allows me to work with things such as breadboards, circuit components, etc. Last but not least, there are many career paths to choose from as doing EE opens a lot of doors in terms of career possibilities. Now, just to touch on the student life aspect here at NUS, let me introduce to you guys some of the activities that I joined before Year 1 started. I signed up for quite a few freshman orientation programs, namely CDE Orientation Week, Electrical and Computer Engineering Camp, and CDE Reg. These freshman orientation programs allowed me to make new friends and learn more about NUS and CDE, which was very helpful as I came into university feeling quite lost. In Year 1, I actually ran for the position of Rag and Flag Director under the NUS Students Design and Engineering Club, which is the main faculty club here at the College of Design and Engineering. Together with my committee members, we planned and executed a successful freshman orientation program for 100+ incoming freshmen, with the main highlight being the actual performance, which was held at NUS U Town Green in front of thousands of people. I also joined the NUS varsity cheerleading team and was lucky enough to be given the opportunity to represent NUS at the national level. Moving on to Year 2, I ran for elections again, this time for the positions of President at the NUS Students Design and Engineering Club and a Council Chairperson of the NUS Students Union. Currently in my role as President, I spearhead a management committee consisting of 26 members in advocating for and representing the interests and needs of 6,000+ students at the college, NUS Students Union, and university levels. Being in these positions have allowed me to develop not just personally, but also professionally, which is something that can't really be achieved in the classrooms. Having covered the student life aspect of my university experience thus far, I would now like to share with you guys what I like about the EE program here at NUS. Overall, I think that the courses here are all very interesting and the learning experience is also extremely enjoyable. I am really enjoying these two courses which I am currently taking, EE 2027 Electronic Circuits and EE 2023 Signals and Systems. EE 2027 allows me to learn more about both transistor and operational amplifiers. It also describes how functional analog circuits, which can be applied to solving complex engineering problems, can be designed and analyzed using operational amplifiers. EE 2023, on the other hand, allows me to see how signals can relate to linear time invariant systems. On top of the courses they can take here at NUS EE, there are also many other opportunities. You can diversify or deepen your learning as there are many different second majors, minors, and specializations to choose from. You can also apply what you have learned outside of the classroom through technical CCAs, such as Bumblebee, RoboMaster, and FSAE. There are also plenty of networking events and company talks to help prepare you for the workforce. To end off, I would just like to share some tips for prospective students. I think it's very important for you to manage your time wisely, as at times, you might feel like there's too little time but too many things to do. Another tip is to not shy away from approaching your professors for academic support, as they will always be there to help you. And last but not least, use your time here at NUS to explore new things, as there are a lot of opportunities out there for you. Try to pick up a new hobby or learn new skills. You won't regret it. That's the end of my presentation. I hope that my sharing was able to give you guys a greater insight into what life here at NUS Electrical Engineering is all about. Thank you.
Hi everyone, my name is Zhiguo. I'm here today to share with you more about the Industrial and System Engineering program. To get started, I would like to play a video about the program.
Did you know that Singapore is the largest and busiest transshipment port in the world? Or that Singapore is ranked first for efficient healthcare? Although they may seem very different, both involve complex systems of systems whose success depends on how they are managed. This is where the methodical approach of industrial and systems engineering comes in. First, we analyze the problem through data analysis and modeling. Then, we innovate solutions that integrate seamlessly. Third, we improve solutions through optimization techniques. And finally, we arrive at good decisions that optimally balances the gains and risks based on rigorous decision analysis.
We have been training engineers in Singapore since 1969. We focus on combining a business mindset, modern management approaches, and multiple analytic skills to help organizations devise and implement ways to do things better. Our curriculum gives students great choice, breadth, and flexibility in charting their learning journey. For example, students who wish to broaden their knowledge and skills in a complementary area can pursue a second major or even 2 minors across the different faculties and schools at NUS.
As an ISE student, you have access to a wide range of internship opportunities, from finance to IT to engineering. Internships provide opportunities to learn skills that are impossible to learn in a classroom setting. In my internship with Shopee, I got to pick up important soft skills like project and stakeholder management.
Going on exchange pushes you out of your comfort zone and broadens your perspective. ISE students have a wide range of good schools to choose from around the world. In my case, I was fortunate to secure an exchange at Georgia Tech, which has the best industrial engineering program in the US.
As an ISE student, you will undertake a real-world consulting project, providing you with genuine industrial experience and greatly enhancing your employability. This will build analytical, computing, and managerial skills that can be applied across multiple industries, including business and finance, digital technology, government and services, manufacturing, and supply chain and logistics.
Did you know that Apple CEO Tim Cook is an industrial engineer by training? As we enter into Industry 4.0 and the digital economy, companies need individuals with ISE skill sets to efficiently adopt and apply the proliferation of new technologies.
Are you ready to make the world better?
To help you better understand what is industrial and system engineering, I would like to explain what do ISE people do. Unlike other engineering areas, where you can actually see the system, the robotics, or the buildings that you actually construct, the difficulty with system engineering is you often don't really see the system because the concept of system is often abstract and not something tangible you see over there. So loosely speaking, what is a system? A system is a set of things that are working together or interacting with each other. For example, we can have a logistics system where you have a warehouse of products to be delivered to different stores and factories, and you have the delivering trucks going around to pick up all the orders. And in this system, one of the problems that the system engineers might be interested to study is how to plan on the traveling route so that the total traveling distance for the delivery trucks can be minimized. And another example of system may be hospital, where you have the different healthcare professionals, the doctors, the nurses, and also the patients and the medical facilities. And one of the problems that ISE people study is how to optimize the appointment scheduling so that the queuing time for the patients can be minimized. And another example will be airports, where you can actually schedule the different flights so that the delay or the waiting time of the customers can be minimized. And we are called industrial systems engineering because we are passionate in solving industry problems in a diverse range of industries. For example, logistics, business, technology, energy, healthcare, and so on. And at the end of the day, what value can ISE people contribute to the industry? We focus a lot on the holistic view of the system, rather than looking at individual parts separately. And because we adopt a holistic approach, or we call the system approach, to ensure that all components of the system work harmoniously to achieve a design goal. And if we just focus on one individual parts at a time, that may actually lead to a local optimization, which might negatively affect the overall performance of the organization. For example, if you are running a company, we want all the departments to work collectively towards a common goal, rather than each individual departments work on their own goal, which might also compromise other departments' benefits. To give you a more in-depth understanding about the ISE framework, I'm going to introduce some of the tools and techniques that we train our students. Here I highlight 4 key areas: the data analytics, the system modeling, optimization, and management, to help with my explanations. I'm not going to explain each one of the aspects one by one. First of all, let's look at data analytics. And in order for us to better understand the system, we have to first have a good understanding about the problem. So that's where the data analytics come in. And our students are well trained with data analytics skills like machine learning, data visualization, and data mining. So after having a good understanding about the system, we will further study and understand the system through some of the system modeling. That's where we train our students with the programming and the computational skills. And some of the modeling skills we use include system dynamic modeling and simulations. And for example, we can actually build a digital twin of the airport system where we can test different potential interventions and policies. And because it's going to be time-consuming and expensive to roll out the real system, so in a simulated environment, we can actually test all the possible interventions without bringing any potential interruptions to the current system. And as the system engineers, we are not satisfied with just coming up with one feasible solution. We are more interested to come up with the best solution, or what we call the optimal solution. So most of the time, when we actually face with a problem, there are more than one options or more than one solutions. This is where our students are well trained with the technical skills to identify the most optimal solution. And our students are equipped with expertise in management principles and financial decision-making skills. They apply them to complex projects and operations in multidisciplinary environments. And some of the courses and trainings we provide to our students include project management, finance and cost analysis, quality management, and so on. And at the end of the day, it's all about decision making. If you actually think about it, every one of us are making decisions every day, every moment, right? As individual, we need to decide what clothes to wear every day, what should we eat. And as you are watching the video, you are going to decide which major you are going to choose. And as for the companies, they need to decide on the investment strategies. And ISE is really the science to help the company and the individuals to make a more informed and optimal decision. And the logic of our methodology is first to analyze the problem using some of the data analytic skills, and then come up with a system model or simulation model. And from there, you propose some innovative solutions. And out of all the solutions, we try to identify the most optimized solution, and then comes to the decision making. And in order to achieve all this in a very rigorous manner, we train our students with all these technical skills, including linear algebra, calculus, statistics, operations research, system design thinking, and programming. As you can see, these techniques are not something that you can easily pick up. That's why our design of curriculum provide a very systematic training to make sure our undergraduates are graduated with all these skills properly. And under the general ISE umbrella, the students may also wish to go a bit deeper in some of the specialized area. And the department offers these 3 different specializations. For example, if you are interested to know more about supply chain, you can pick up some of the supply chain modeling courses, some of the manufacturing logistics courses, facility design and layout, revenue and pricing management. And secondly, we also have the analytics and decision intelligence specialization. This is where you get to learn more about the advanced machine learning models, deep learning models. We also teach some of the most recent trends like the generative AIs, the ChatGPT models, and this is where you pick up some of these skills. And lastly, we have the sustainability specialization. I think everyone is trying to move to the carbon emission reduction, so this is going to become something very useful and commonly used in many industries. So you get to learn more about the carbon market models, the energy system of modeling and optimizations. And you also have the flexibilities to design and build your own degree. As you can see at the bottom, we have some of the common curriculums for all the CDE students. Then on top of that, you have the first major, which is Industrial and Systems Engineering. And beyond that, you get to choose out of the 3 specializations. And some of our students actually wants to explore a completely different field or a complementary subjects. For example, a lot of our students choose to take a second major in computer science or take a minor in economics and quantitative finance and so on. And what you see here is not the only possible combinations. In fact, the department is always happy to sit down with you to understand about your interests and discuss with you and come up with the suitable plan for each one of you. And apart from the normal lecture kind of class, the department also offers students a lot of opportunities to get immersed with industrial experience. And one of the capstone projects that our students will work on is the system design project. And this is a course which spans over 2 semesters, and you get to work with a team of 4 to 5 students, and you will be guided with one industrial supervisor from the collaborating company and one academic supervisor from the departments. And here I list out some of the collaborative companies that we work with in the past. And of course, this is not all of them. Due to the space limitation, I cannot list out all of them. If you are interested, feel free to scan the QR code. This is where you get to find out more about all the past student projects that we have done. As you can see, the companies that we collaborate range from a very diverse range of industries. We have e-commerce, we have healthcare, we have manufacturing, we have semiconductor, we also have consulting and so on. And I think one of the issues that our undergrad students have is that not sure about what they want to do in the future. So here we provide a lot of industries for them to explore. So they get to experience those industries according to the interests. And a lot of our students identify their future career paths and future career interests through some of these industrial experience. And some of them even receive job interview opportunities or even return offer after working with some of these companies. Another capstone project we offer is called the Independent Study course. And this is for those who are interested to explore a bit more about the academic career. And let's say you are not sure about whether you are suitable for a future academic career. And this is an excellent opportunity for you to explore. And you get to work with one of the professors from the departments and one of the academic projects. And you get to be guided from all the way from the start, identifying the topic, doing literature review, and coming up with the research methodology, and propose some of the model, do computational study, as well as do an academic presentation. And here you can see some of the topics of the projects that are proposed by our own students. For example, they study about the pricing strategy for the bike sharing system in Singapore, or they study about the electrical vehicle charging ports design and allocation in the Singapore society. And our department also hosts a Center of Excellence in Modeling and Simulation for Next Generation Pod. And the aim of the center is to become the leading research center in logistics, modeling, simulation, and optimization for the next generation pod. And our department works very closely with the center, the professors, the research team, and the graduate students over there to craft out project topics and also internship opportunities for our students. So if you are interested in logistics, modeling, and simulation, also the pod management, I think we have a lot of fantastic opportunities for you. And this is just an overview of the sectors that our past ISE graduates work on. As you can see, a lot of them work in the finance and business areas, and a lot of them work in the government and service areas. And there are also quite a lot of them work in manufacturing and logistics, digital technologies, and many other areas. I think one of the good things about ISE is it can really give you a lot of potentials, right? As you can see, if you are not sure about which career path to choose from, I think ISE has a lot of potentials. And we also provide the LinkedIn profiles of all our past alumni on our department website. So feel free to take a look and see whether some of their career paths might be of interest to you. So just to summarize my presentation, I think when it comes to the university experience, students normally look at these 4 aspects. Of course, the curriculum, the study, and then the industrial experience, because we don't want our students just to study, we want them to explore the industry as early as possible. So we offer all the different capstone projects, internship opportunities. And apart from study, we also offer a very vibrant and rich student life. For example, we have this ISE Club. It's the student organization managed by our own ISE undergrads. So they organize events, they organize workshops, they organize competitions. As you can see from the picture, they just organize one-night cycling events after the final exam. And we also have an extensive collaborations with many top universities around the world. So if you actually join our departments, we actually have a lot of overseas exchange opportunities or summer school and winter school opportunities for you to explore. And feel free to scan the QR code or visit our department website to find out more about us. On behalf of the departments, I would like to warmly welcome every one of you and really look forward to seeing some of you in the campus.
For today's agenda, I'll be talking about my background and share a bit of my experience studying in CDE, followed by some interesting projects that I took, as well as other exciting student life experiences that you can expect when you come to NUS. So hi, my name is Darryll, and I'm an Industrial and Systems Engineering student, year 3, and I was the Vice President External for ISE Club. I was also the subcommittee for CDE Club, and so why did I pick ISE? It's because I didn't really like A-level science, and the science practical was worse. And I really love efficiency. So I picked ISE when I was scrolling through and looking through the engineering courses. So what's my career aspiration? Is to have high pay and low effort. So some experiences that I have in CDE, I can sum it up in 3 things. So the good, there's a lot of quantitative as well as qualitative modules that you can take. The bad would be the high workload. And the ugly, 2359 deadlines. I hope you all will be prepared for that. These are some of the projects that I've done, just a few. So on the left, you can see a gaming project. So why did I start this gaming project as a side project? It's because I was inspired by certain modules that I took in year 1. So I went to further explore the different languages available, like JavaScript and HTML and CSS. And then I went to watch YouTube videos and I created this side project. So a lot of people like to do like back-end stuff because that's the hype, but I was more interested in UI UX type of projects. On the right is an Excel project. So basically I took a core mod known as IE1111R and I was inspired by one of the projects that I had to do for an assignment. It was to deal like poker card and deal the cards as from the deck. So I just expanded that, and I was thinking, why not do it for tarot card reading? So what are other experiences that I have in CDE? I took an internship. So I was part of LTA as a systems engineer, and I did a particular project known as model-based systems engineering. So it might not be very relevant to what I took for my modules, but the concept of systems thinking really helped a lot. And it was one of the reasons why my supervisor picked me in the first place. Secondly is student exchange program. So I know a lot of people are very excited for exchange program. So I went to Hong Kong University of Science and Tech, and I met a lot of friends from around the world. My apartment mates were from Europe, Norway, Sweden, France, and even America. So just take note that exchange program doesn't mean that you really have to study. Honestly, I would rather you go there and network, because it's really very fun to have friends from around the world. Thirdly would be the student life. So as you all know, I'm part of ISE Club. So we organize a lot of events for our course mates. Some would be like night cycling, the more exciting stuff, and orientation camps. I also did CDE Club, and I was part of the house committee, as you can see at the bottom picture on the right. So those were my house call members, and we are still close friends even till today. So just know that when you come to NUS, be excited about student life, not just study all the time, because the friends are the ones that you bring out after you graduate from NUS. So here are just some survival tips that I recommend all to have while you prepare yourself to come into NUS. One trait will be discipline. So having discipline will really help you to meet your deadlines and complete your work on time. Secondly is to study smart. When you study smart, you don't waste your time firstly, and you make better use of the time that you have, since it's already limited. Thirdly, time management, just to tie back to studying smart. And fourthly, networking. So as I said about student exchange program, it's not just to study, it's really about networking, making friends with people from other backgrounds and cultures, and to learn more about them, because we hardly leave the country, and it's a really exciting experience to have friends from around the world. So I'll leave you all with a quote. I am the master of my fate, and I am the captain of my soul. So regardless of whether you come into NUS, I hope that within your journey, you know that you are in control of whatever path that you take, and I hope you do the best in whatever you do. Okay, thank you all for listening to my presentation.
Hello, and a warm welcome to our introduction on mechanical engineering at NUS. My name is Christina Lim, and I'm one of the deputy heads of the mechanical engineering department. You're probably wondering, if I graduate as a mechanical engineering major, what is it that I would actually do in my job? Well, one of the main activities that mechanical engineers are involved in is the design of products that carry loads or experience forces. So a common example is that of a smartphone. The housing of the smartphone, the touch screen, the camera, and the vibration, these are all designed by mechanical engineers. So here is another example, which is an exoskeleton used by the SAF. You will see that in this exoskeleton, the forces of your field pack are actually distributed such that this can prevent any injuries as well as fatigue. Of course, mechanical engineers are also involved in the design of complex systems. Aeronautical engineering is a subfield of mechanical engineering, and all the major components of an aircraft are actually designed by mechanical engineers. Another area of mechanical engineering that you might not have known about is energy. Here we have a gas turbine, which is part of what produces most of the electricity in Singapore. Outside of fossil fuels, mechanical engineers are also involved in the development of things like wind turbines, batteries, and fuel cells. Another important aspect of energy is actually heating and cooling. Cooling is particularly important in tropical Singapore. mechanical engineers develop new cooling systems that are sustainable and more energy efficient to cool the environment. Mechanical engineers also develop cooling systems for electronics, from the tiny microchip to huge data centers. Finally, mechanical engineers also manufacture the products and systems that we design. There are hundreds of manufacturing techniques, and mechanical engineers would be the ones involved in choosing the most suitable materials and methods to bring the design to life. So you can see, mechanical engineers are everywhere. The skills that you learn in your mechanical engineering education are very broad and versatile, and they will always be needed in a modern economy. You might have already heard from other talks that our curriculum consists of 40 courses, typically read over 4 years, and they can be grouped into 3 major segments. First, we have 15 courses that are prescribed by NUS and the college. Then we have 15 courses that are foundational to mechanical engineering. And finally, there are 10 courses where you can choose whatever electives that you would like. Now, let's take a closer look at the courses within the mechanical engineering major. If you come from a JC or an IB school, some of these subjects will seem quite alien to you, but they actually build upon the math and physics that you have already learned. So you can see here the mathematics is derived from the mathematics and further mathematics that you have probably done at A levels. Also, many of our subjects are related to the Newtonian physics, waves and oscillation, as well as thermal physics that you have studied before. About half of our undergraduate students in mechanical engineering come from polytechnics. For poly students, you are given advanced placement credits, which essentially exempts you from certain courses. Now, these exemptions come from all 3 components of our curriculum. In the common CDE curriculum, you are exempted from courses on prototyping and design thinking, because most polytechnic students with an engineering diploma would already have studied this. You would also be exempted from the compulsory internships, since many of you would have already been on internships while you are studying at the polytechnic. And polytechnic students only need to read 5 unrestricted electives. So these exemptions make up 9.5 courses, which would cover about 1 year. So polytechnic students would enter directly into year 2 and be able to graduate within 3 years. More importantly, you can see that the exemptions are not part of the mechanical engineering foundation, so you would not actually be missing out on any of the fundamentals by going directly into year 2. From other talks by CDE, you probably would have seen suggestions of how to fill that 10 unrestricted elective space. If you would like to further explore in depth into mechanical engineering, you could choose a specialization or 2. You can also choose to branch out to complementary areas within engineering or outside of engineering through minors or second major. Do note that for polytechnic students, because you're already exempted from 5 unrestricted electives, in order to read a second major, you would need to offer 5 extra courses. You can mix and match electives, specializations, minors, or second majors to build a skill set that caters to your interests and aspirations for a career. For example, if you're interested in working in aviation or the aerospace industry, you could do an aeronautical engineering specialization. You could then follow that with more ME electives or even another specialization within ME. I would like to highlight a new exciting second major in computing, which is available to all CDE students. With your mechanical engineering knowledge and a second major in computing, you will have an edge in future jobs such as cybersecurity. Cybersecurity has moved on from protecting just websites and data into the protection of highly networked physical infrastructure such as the MRT and power plants. Now let's take a closer look at the specializations within mechanical engineering. A specialization would require you to do 5 courses each. They can be either technical electives or projects. So this depends on which specialization. You can apply for the aeronautical engineering specialization as well as the robotics and industry 4.0 specialization at the point of entry into NUS, or you can opt for these specializations later after a semester or two. The new second major and minor in computing for CDE students requires 10 courses if you opt for the second major or 5 courses if you choose to do a minor. The courses in this curriculum will complement your engineering skills in areas such as programming, data, AI, computer simulation, and the automation of mechanical systems. As with the mechanical engineering specializations, you can apply to do a second major or minor in computing at the point of admission to NUS or later during your studies. To give you an indication of how to curate your own skill set with specialization second major or minors, here are some jobs that have actually been offered by some top companies in Singapore in the past year. You can see that they cover a wide range of areas in mechanical engineering. Once again, this shows that the mechanical engineering degree is very broad and versatile, and you will definitely be able to find a job that suits you. Now come to the big question. Should you do ME? Maybe this checklist will help you. First, you must not hate maths. You don't need to love it, but mechanical engineering does have its share of mathematics. If you like to know how things work and tinker your way around, mechanical engineering may be the degree for you. Also, you would probably like to have more hands-on experience with physical objects and systems compared to maybe electronics and electrical. So if you want to have very versatile skills and access to a broad range of careers, and as well as skills that will never outgrow our physical bodies and our physical environment in the modern economy, then perhaps mechanical engineering at NUS may be for you. So maybe you've decided, okay, I'm going to give mechanical engineering a try, but then why choose NUS? You have seen earlier that our curriculum is very flexible. It also offers you different modes of learning, whether it's through electives or hands-on projects, as you have seen in other of our talks. There is also no penalty for switching different engineering majors, so you could start with mechanical engineering, and maybe if your interest develops elsewhere, perhaps you could even switch to materials engineering, or you could go to chemical engineering, and there would be no restrictions with your switching. You're also able to pick up any specializations, second majors or minors, or drop them if they do not suit you after a while. Did you know there's a great free system at NUS? You can actually choose to waive the results of up to 8 courses from your honors calculations. This is so that you can enjoy exploring subjects that you like without fearing about the exams and the results at the end. The large NUS ecosystem also offers you a wide variety of courses to fill up your unrestricted electives. You could choose language courses. You can also choose even music courses. There's also the accompanying student life as well as other facilities that come from being in such a large university. Mechanical engineering has the largest number of exchange partners among the engineering majors. For example, we have exchanges with Oxford, Cambridge, and Imperial College in the UK, as well as many top universities in the US. And surely you would have heard of our NUS Overseas Colleges, or the NOC. This is where you get to intern at exciting startups at 19 different locations worldwide. So what are you waiting for? Find out more about mechanical engineering at NUS through our website. We hope to see you soon at our other events and eventually on campus. Thank you and goodbye.
Hi, I'm Alicia Lim, a Year 4 mechanical engineering student with a second major in innovation and design at NUS. Throughout my 4 years in NUS, I have benefited from the many opportunities and resources as a mech eng student here, and I'm here to share more about them. Apart from the school, halls, RCs, CCAs, there are many other chances to pursue your interests. At ME, there are 4 main categories. First, the competition projects. second majors, minors, and specializations, internships, exchange programs. Starting with competition projects, there are several competition teams that ME students can be a part of, such as Formula SAE, Bumblebee, RoboMasters, and Aero NUS, which I was a part of. The Aero NUS team participates in the yearly fixed-wing UAV design, build, and fly international competition that is held in the US. The competition challenges us to design and fabricate a radio-controlled, electric-powered aircraft to meet a specific mission profile. During the course of a year, Aero NUS batch will design an aircraft with the goal to meet the mission requirements as well as optimize scoring, followed by manufacturing, conducting flight tests. Here's how the competition in 2022 was like. This is the work and rest area, which was in an aircraft hangar, while the image at the bottom is the 2022 team waiting for our flight mission turn. Secondly, on top of our mechanical engineering major, we can opt to take on second majors, minors, as well as specializations. I took on a second major in innovation and design as I had an interest in designing, manufacturing, and testing. Additionally, I took on an aeronautical specialization and got to do a semester-long exchange at ISE Students, a reputable aerospace school in Toulouse, where the HQ of Airbus is at. Thirdly, there are many opportunities to take on internships at industry-leading organizations. It is value-adding to take on internships during the course of our undergraduate studies, as it enables us to gain real-world experiences on top of the theoretical knowledge we learn in school. NUS portals like NUS IAAS, NUS Talent Connect are portals that students can use to apply for internships, where I was fortunate to intern at Airbus and Singapore Airlines during my time in NUS. Moving on to exchange. There are short-term as well as long-term exchanges that students can go on. During my 4 to 5 month long semester exchange, I got to learn and immerse myself in the French lifestyle, school environment and culture, as well as explore Europe. While if you prefer a shorter exchange, there are opportunities to go on summer and winter exchanges. I went for a summer exchange at Hanyang in South Korea. Although it was a very short 1 month, it was still a very good chance to experience life as a Korean student, try traditional Korean food, and make international friends. Lastly, apart from the fun extracurricular projects and activities, the core mechanical engineering curriculum at NUS equips us with the key knowledge required as a mechanical engineer, such as engineering, innovation, and modeling, where we learn to use the SolidWorks software to do 3D computer-aided designs. The manufacturing processes course introduced us to the different manufacturing processes and technologies available for metals and plastics, while the introductory fluid mechanics course taught us the behavior of fluids during various flow conditions. For more details on the Mechanical Engineering undergraduate course at NUS, do visit our official ME website found here.
Hello and welcome back. We hope that the presentations earlier have provided valuable insights into our programs and offerings here over at NUS CDE. Now, we are moving into an exciting segment, the panel question and answer session. This is your chance to engage directly with our esteemed panelists and get answers to any burning questions you may have about our programs, curriculum, student life, or anything else related to NUS CDE. So, without further ado, let's dive into the Q&A session. If you have any questions, feel free to type them into the chat box. Our panelists are here and ready to provide you with the information you need. Remember, the more questions you ask, the more you'll get out of the session. So, don't be shy. So, to get the ball rolling, the first question to the students would be, any advice on how to enrich my campus life?
So maybe I can take this. My name is Qing. I'm a year 2 electrical engineering student. I think over here at NUS, there are a lot of opportunities for you to enrich your student life. For example, if you're interested in picking up a new sport, you can just easily join a varsity team or recreational team, and you can hone your skills in the sport over there. And also, let's say you're interested in picking up other hobbies, like for example, cooking or all sorts of different hobbies. You can also take up different CCAs, and then you go for those evening training sessions or evening practice sessions to enrich your student life and also learn something outside of your classroom. In terms of something that's maybe from a more professional standpoint, I do believe that there are many events here that allow you to actually connect with industry professionals, even like alumni, your professors, and people like that. So, for example, industrial talks, industry visits, and networking events. So you can actually attend all these events to enrich your student life, reach out to people outside of your classroom, and learn more about your industry, about your curriculum, and stuff like that. Of course, you also have your student clubs you can join. We can help you hone your leadership skills and also meet peers from different majors and also learn how to organize events also. And on top of that, there are a lot of fun events out there for students to take part in. For example, you have welfare pack giveaways, and you have different events where you get to play maybe like arcade games and even do things that are related to your major. So I would say a lot of opportunities out there for you to just sign up. It's very easy and it's free of charge also most of the time. So you can just go for it, and that will really enrich your student life because you get to learn a lot of things, do a lot of things that you can't do in your labs, in your classrooms, in your lecture halls, and stuff like that. And also on top of that, you can also join different programs such as our exchange program and also NOC, which allows you to actually go overseas to experience learning in a different culture, in a different country. And also, if you're interested in entrepreneurship, you also can get to experience how it's like interning at a startup or even starting your own company. And I think on top of that, you can also stay in halls and RCs. And over there are also a lot of events, and you can also take part in sports, cultural activities, which allows you to broaden your perspectives and also meet new people. So I think all these add up together, it will really be a very interesting student life for you, and you have so many options to choose from, something that you can't really do outside of university. So I think, yes, it's a very all-rounded education, holistic education for you guys lah.
Yep, thank you, Qing for the answer. Yes, I do remember that, Barbara, you were in RC4, right? So maybe you'd like to share how is your typical week like together with being a computer engineering undergraduate and your life in RC4 together?
Okay, I can say more about like staying on campus. I think it's definitely like very interesting, and I feel that a lot of people right now is thinking whether to join like RC or hall. I feel that like both is equally fun, but for me I prefer RC because I think it's like more holistic. Like it's more like balance. You can have like the fun as well as like prioritize your studies more, because I feel that a lot of people in the hall, since they have to like stay, they want to stay for like 2 years, so they have to like keep going for a lot of CCAs. But then RC is like compulsory stay 2 years. So the things that we join is like more fun, and we are not pressured to do things that we don't want to. So I feel that RC is like a more balanced lifestyle. I have quite a lot of fun, like try out new things, and it's like very open. I go for like coffee sessions, tea session, and like basketball even sometimes. And like I think it's much more like fun. And like people can create their own like IGs also if they want. Like some of my friends, they created like cocktail making sessions or like perfume making workshops also. So how I balance my time is like, a day in my life is usually most of my lessons is in the afternoon. So I'll eat lunch with my friends, then I'll go for my lessons, then I'll come back for like dinner at RC with my OG. Then after dinner, we'll play pool, maybe like do some mahjong, and then like closer to like midterms or finals, we like study together in the study room. So I think it's a more like balanced lifestyle as compared to hall. And besides that, like some of my student life things that I did in uni so far is I went for like exchange in like after year 1, sem 1 to like Korea. And this year I also went on like a Bangkok trip to like for more entrepreneurship stuff. So I get to meet like a lot of different friends and learn many new experiences. So I feel that uni life is how you want it to be. So if you want your life to be like a lot very exciting and have a lot of different activities, you can just sign up. I feel that NUS is very open to a lot of new opportunities, and you can make many new friends here if you want.
Yes, thank you, Barbara, for the sharing. Wow, a very vibrant campus life indeed. So maybe let's dive straight into the more serious curriculum matters with the professors. So Prof. Arthur, how do computer science and computer engineering differ in terms of the curriculum and the focus? Would you like to share more about that?
So I think the computer engineering program actually has a lot of hardware, software interaction type of module involved in it. And if I take the example of your smartwatch, right? So the computer engineering will focus more on the electronics, the IC design, as well as the low-level type of programming things. And then for computer science, it will be more on the application and the algorithm part of it. Yeah.
Thank you, Prof. Arthur. So maybe we can have Dr. Wang for the next question. Earlier in the previous sessions, Prof. Aaron actually mentioned about systems engineering being a second major. So can you comment, what is the difference between doing ISE as a first major versus a different first major with systems engineering as a second major?
I think in general, taking ISE as a first major is actually more demanding in terms of the workload because you are going to take more credits as compared to a second major. And you are going to become a system engineer after graduation. And we do have graduates working in different industries. And we are going to train our students very systematically, all the way from the foundation models, the system design thinking, and the simulations, data analytics, and so on. But let's say you are actually passionate to become, let's say, an electrical engineer or mechanical engineers. I think it's still going to be beneficial for you to take ISE as a second major because most of the time you are not working with one system in isolation, and system design thinking will actually help you to come up with a better solution as a whole. I think that's the key difference.
Thank you, Prof. So maybe next up, there is a question from Prof. Christina regarding mechanical engineering. So in the aspects of specialization, how can students interested in aeronautical engineering pursue their interests within the framework of mechanical engineering? We'd like to comment about that.
Right. So if you have been paying attention to our earlier talks, you will know that specialization requires 5 courses. And so you have 10 unrestricted electives available to you if you come from A-levels, and 5 unrestricted electives from Poly, for the Poly students. So a specialization in aeronautical engineering is what we can offer for 5 courses. So aeronautical specialization is actually a subset of mechanical engineering. So in our common curriculum for mechanical engineering major, you'll be learning things like fluid mechanics and mechanics, applied mechanics, which are then directly applicable to what you will need in aeronautical engineering as well. So therefore, we prepare our students. If you take up the aeronautical specialization, you will take on further aerospace and aeronautical related courses such as propulsion, such as aircraft structures, and so on. So Alicia, who is here with me and whom you have, which allowed her to intern at Airbus and SIA.
Thank you, Prof. Christina. So speaking of Alicia, could you kindly share some projects or any interesting courses that you have taken part in?
So for the projects, I've taken on several, including a competition project with Aero NUS, which is a fixed-wing UAV competition team. Apart from this competition team, if you are interested in aerospace, there are others like the Singapore Amazing Flying Machine competition, which is organized by DSO and Science Center. And other projects such as taking on a second major in innovation and design, I get to do 2 year-long projects, and one of them I did it on UAVs to tackle reforestation. Yep, thank you.
Yep, thank you, Alicia. So maybe along with the aspects of Darryll, could you kindly share, are there any opportunities for industrial and systems engineering students to participate in competitions or any industry-sponsored projects?
Yeah, so recently we just ended one of our case competitions organized by ISE Club. So yesterday we held a business analytics case competition in partnership with Micron. So that's one of the few events that we will hold as a student club in partnership with external industry leaders. So some projects that from the department side will be our systems design project, which is a year 4 group internship that all the year 4s have to complete, and then we'll do like an internship for as a group with your fellow peers, and then you'll do it with many different companies. So some companies like Micron, Infineon, are just some examples that we have. Yeah, so you can look forward to Micron BACC next year as well. If you're a pre-uni student, you can always take part in this competition to see whether you're interested in what we're learning. And then you can also look forward to our systems design project. Yeah.
Yes, thank you, Darryll, for the sharing. So maybe a very general question to the floor. What are the future career prospects that graduates can look forward to when they graduate from each individual major? Maybe Prof. Christina, you would like to share more first?
So mechanical engineering is foundational to many of our industries. So as long as we're physical beings in a physical world, you find that in urban transportation, future cities, aerospace, aviation, manufacturing, all these industries will have some components of mechanical engineering, of course, some more than others. So you will find that there are huge range of jobs available to our graduates in mechanical engineering. It's up to you to decide which particular area you would like to be in. And I think that mechanical engineers are always in need, and if you look at the latest graduate employment survey, our graduates are actually doing fairly well in terms of employment, in terms of the percentage as well as the starting pay. So there are lots of opportunities for mechanical engineering graduates.
Thank you, Prof. Christina. How about Prof. Arthur from Computer and Electrical Engineering?
Hi. Yeah, so I think for electrical engineers as well as computer engineers, your unique training in hardware as well as software integration allows you to embark on many different types of career path, right? So we have students that work as AI and data engineers, even cybersecurity engineers. And one other example is, for example, in the healthcare sector, as the country try to move many of the hospital services closer to the communities, you need a lot of digitization and those type of skill sets. And electrical and computer engineers are actually very suited for this type of roles. Yeah.
Thank you, Prof. Arthur. How about Dr. Wang from ISE?
I think for ISE, I think one of the good points is being flexible. As you can see from our curriculum, we actually offer courses which covers a very wide range of topics. We have data analytics course, we have simulation course, statistical modeling, and also project management, and so on. Right. So as you can see, our students, they actually work in all kinds of different industries. They work in the financial industry, supply chain, business analytics, right? We actually have 3 different specializations. One in supply chain management, one in smart and decision intelligence, and another one is actually the sustainability. Okay, so I think the best thing about system engineering, if you haven't decided what is your career path, I think that's probably a good choice because we actually get to work in all kinds of different industries.
All right, unfortunately, it seems like we are running out of time for today's live Q&A session. However, fret not, if you have any further questions or would like to delve deeper into our programs, I encourage you to visit our NUS CDE website. There, you'll find a wealth of information to satisfy your curiosity. We have come to the end of this breakout room, so do check out other programs happening at Breakout Room 3. We have Civil Engineering, Environmental Engineering, and Infrastructure and Project Management. And in Room 4, we have Biomedical Engineering, Chemical Engineering, Engineering Science, and Material Science and Engineering. We'll see you there. Thank you.